I've got the three common defects we find in bowl turning: over-rubbing of the bevel, no bevel contact, dull tool. I'm going to start with the over-rubbing of the bevel, show you where it came from, how to eliminate it, and then we'll follow on to the next two. I'm using a 1/2 inch diameter bowl gouge with a 40-degree bevel, and the wings from the center out are 40 degrees, so I call it a 40-40 bowl gouge with an 80-degree included angle, bevel to wing, straight wings on this, no curvature. And the cut I'm using is push cut all the way around, which means the control must come from my right hand. If I use my left hand to control it, I'll either create the bounce or the scoring by pulling the bevel off, and neither of those are desirable. So we're going to fix this one first and take away the bounce. Before I apply technique to fix this bowl and the other two bowls, I've set everything up correctly. I've set up my height of my tool rest, center to center, center of the gouge is on center with the bowl blank when level. Tool rest at the correct angle and distance so I can cut all the way around. It's a curved cut, so I have my right foot forward. I've set my speed at 1600 RPM, which is suitable for this bowl blank. It's around 7 inches in diameter. And now, as I do the cut, I've got to ensure that I do the correct grip with my left hand. Now, I don't recommend the overhand grip because it's very hard and tough on my wrist, and you tend to push or pull with this. It's a very dominant grip. So it's a pinch, as if I'm taking the tool with my fingers and laying it on the tool rest. My fingers must come over the top of the tool, not underneath. Otherwise, my thumb becomes a dominant force here, creates a bounce by pushing. I don't want to bridge the flute, either in the flute or on top pulling down. I need the left hand pulling down, no control. It's not pushing, no pulling. It's just following the gouge round, adding weight and position for the start of the cut. And at the end, I'll use it to squeeze back towards my right so I don't lunge through at the end where I'm pushing with my right to create the force of cut, but I need to use a brake and slow it down. And then the swing comes from the right hand. There'll be a little twist, a little lift, and obviously push to get all the way around. All of those four controlling factors controlled by the right hand, and I have enough leverage in this handle to suit this blade for this cut. So the bounce will occur if I allow my fingers to drop below center, or if I bridge across here because my thumb can't pull down, it's only able to push in. So I want my left hand to be neutral, not controlling at all, just adding the weight, then I'll eliminate the bounce. So I've cut around the outside without any bounce. I don't have any torn grain because the gouge was sharp, and I've got the form I wanted because I set up my position to be able to swing correctly to produce the shape that I have. The bounce before was created with my left thumb, and to eliminate that, I ensured that I had a neutral grip on the tool as I went around. There was no pushing in force at all. And if the bounce starts, it can't be eliminated once it starts. You have to go back behind and start the cut again. And because push cut gives you such a great finish, then it is important to ensure that we don't destroy that finish by adding extra force with our left. All the control, right hand. This particular defect on this bowl was created the opposite way to the last one. The last one was bounce. Here this was created by not pushing in with the thumb, but actually pulling the gouge around with the fingers. And so what I have is the nose of the gouge scoring, and you can see it created tremendous damage on this piece, because whilst you're scoring with the nose of the gouge, it's an unsupported cutting edge, so you're technically scraping with the nose and killing the cutting edge right at the very front, which gives us this horrible finish and all these ridges. This cut, if you were to remove your left hand, would stall. It would actually dig its way in. So it can't actually be done without the left hand. So what we need to do to fix this is ensure the bevel is in line. Again, we don't press on it, but we don't pull on it. And we just hold it down, pinching the same way. And then we go from the base to the top in one pass if we can, with a freshly sharpened tool. I went and sharpened it for this last cut, especially because this wood is slightly spalted, so it needs the best edge possible to be able to cut through these fibers without lifting them. Now the cut went very well from base to the top. There's still a little torn grain here, and so therefore I didn't go deep enough. As I got towards the end, the cut got a little thinner. I need to go back and cut this one more time to remove this little damage here and here. So I'm going to resharpen the tool because it's spalted wood, and even just doing one cut takes the primary edge off. It's not quite as sharp as before. I'm also just going to bevel this edge so we don't get the breakout as well. So the second cut allowed me to go a little bit deeper to get below the torn grain that was there before I started the finishing process here. And again, by not controlling the tool with my left hand, just holding it down, letting it slide and glide on a bevel, not rub, and leaving the bevel in contact, I got the clean cut from the base to the top and no defects in this piece. This particular bowl blank was cut with correct technique. Left hand was not controlling, simply holding the tool down on the tool rest. The right hand was creating the motion to form the shape. The difference was the gouge had been used too long and was dull. So using the exact same 40-40 bowl gouge on this piece of ash, we're going to take one cut deep enough to go below the torn grain, especially here where the end grain is, because this is a mixed grain bowl blank, and eliminate the defect. So the difference between the bowl now and before is I used a sharp gouge, cutting from the base to the top in one cut with correct technique and no controlling with the left hand. I was able to eliminate the torn fibers and finish the piece with a much better finish, only requiring tool marks to be sanded out, not torn grain. So here I have the spherical cut with the three main defects. The first one being the bounce defect, created again by the left hand. The second one, we can see the score marks around here, and that's the opposite to this. This was no bevel contact, being pushed around by the left hand, letting the nose of the gouge dig in as it swung around the corner. And the third one here is simply torn grain. Dull tool, correct technique. For this particular cut here, it's a spindle grain direction. So we're cutting round end grain, but we're trying to cut side grain. Using the same 40-40 bowl gouge, the tool rest position needs to be perpendicular to the work, but parallel with the lathe. And if we put any angle for this particular cut on the tool rest, it won't work. I can't get a good start. And although I'll get a better finish, the overhang is so short in spindle turning that it's not that essential to have the tool rest really close to the end of the cut. So we have to ensure all the setup is correct. The tool rest height, center to center. I've set the angle that allows me to get all the way around. It's a curved cut and I'm turning right-handed, so right foot forwards. The right hand will be creating the lift, the twist, the push and the swing to form this shape. The left hand will help position the tool, it will add weight, and it will slow it down at the end of the cut, but it will not be pushing nor pulling on the bevel or off the bevel as a swing around the corner, because that's what creates these type of defects. And with this sharp tool and the correct speed, I'm running at 2200, I can cut all the way around in one pass. Something to note here though, this is a rechuck piece of wood, so it probably isn't running exactly right. So I don't want to start with a bounce, and I have to find my bevel contact first. So there's a little bounce there. If I start with a bounce, then it's going to continue through the cut. So I am going to level the surface first to give myself a very good starting point for this particular cut. So there was a controlled cut around the outside, deep enough to get below the bounce and to eliminate it. No tone grain because the gouge was sharp and everything else was set up correctly. Now the bounce on this comes from the opposite to what is on the bowl blank. In this direction, it's my fingers that create the bounce because they restrict the gouge from moving sideways and pull it into the surface here. Whereas on the outside of the bowl, it was the thumb pushing in. So I'm just going to create the bounce very quickly and then eliminate it and show you where it came from. So we can see the bounce towards the end of the cut, and I didn't go all the way around because it was starting to get way out of control. The bounce was created by my fingers not allowing the gouge to slide around on the tool rest. I was drawing it back, creating over-rubbing of the bevel, and then the bounce starts to occur, and then it just gets worse and worse. The one thing to note about bounce is it doesn't usually start immediately. If you notice at the top here, there are no bounce marks around the piece. It didn't start till around about here. So it's a progressive bounce. It's almost nothing happening in this area. It hadn't yet occurred, but once it starts, it will keep going and getting worse, and hence I stopped the cut early because it was getting out of control. I'd really got the bounce going more than I even wanted. So here is important not to restrict the movement of the tool. No controlling factor with the left hand. I need to allow to add weight with the left and allow it to swing around, and my left just trails behind, not restricting that movement. And remembering this is a push cut, and there is no other way of cutting round end grain. It cannot be pulled around end grain like you can on a bowl. When we're spindle turning, because this is a form of spindle turning, we can only push the gouge around. And when we're pushing it around, we mustn't restrict its movement. And by doing so, allowing the gouge to slide freely on the tool rest, just adding weight with the left, I was able to make the cut very cleanly, and therefore little sandpaper and that piece would be finished. This defect here, where we can see the ridges around the outside and they go from the beginning to the end, I had to set up to create that defect. Normally the defect would just be part the way around, and that is where there's no bevel contact. Now it's rare to be able to get all the way around without any bevel contact, and to create that I actually had the tool rest set up incorrectly because the tool's coming in at a different angle. So I set up the tool rest wrong at the beginning, so I couldn't actually get bevel contact, and then it was dragged all around using my thumb and pulling with my right, pushing with my left thumb right the way around the end. Normally if you set up the tool rest correct, you won't get the spiral mark or the score mark all the way around the piece. So let's show you how it was created. And one thing I will have to do, once I've created this, it will absolutely kill the cutting edge. I've got to fix the cutting edge. So my left hand was controlling the cut by pushing it round with my thumb. You notice when I took my thumb away, the tool skidded up the work. That lets you know this defect can't be created without the left hand, because simply the right can't control it at all. Without bevel contact, there is no cut at all. It will just always skid. So what I have done, I've damaged my cutting edge, so I need to fix it. Then I need to set up correctly. I couldn't get the spiral mark started all the way around into the end without the tool rest at an angle. When a tool rest is correctly set up, then it can't be wrong at the end of the cut. And let me show you why. So we may start off incorrectly with the bevel out of contact going round, but as we get to the end, there's no way of keeping the bevel off all the way around. It can't be done. So at some stage, the cut would actually fix itself. As you go around, the bevel will be in contact and it would fix at the end. So the problem lies in you've got to set up the tool rest right from the beginning, ensure that you're not controlling with the left and pushing it round, that the tool glides itself, and that we don't also pull it back onto the surface, which was the first defect. So I'm going to go and sharpen this tool because it's definitely damaged and dull from scraping with it for that 10 seconds. I cut the piece twice because I swung a little early on the first piece, leaving too much material to be cut off in one. And as I tried to remove it gently, it actually snapped off. When the fibers snap off, it leaves a little hole in the end because it pulled the fibers out rather than being sliced through. So I went back and recut it again. Again though, making sure that I wasn't controlling with my left hand, that I was sliding on the bevel all the way around, completing the cut, and all the 4 actions that take to make a curved cut, which is lift, push, swing, and twist, are all created with the right hand, the left hand again, just adding weight, positioning, and helping to slow the tool down by pushing back towards the right as I complete the cut. This particular block was cut correctly. However, if we look at it, it has torn grain. It's not severe, but it's very noticeable and I can feel it. So I need to fix this, not by changing technique, but by ensuring I've got a sharp gouge. So my gouge is being resharpened and I follow the same routine as before. A couple of other things that can help to improve the finishes: slow down the feed rate of the tool. The faster you go, the harder the cutting edge is working, the more likely it is to raise or pull out the grain. Secondly is, if you can, but it must still be safe, is to increase the lathe speed. If your lathe speed is too slow, then you're going to have the same problem as cutting too fast. It's a combination of both lathe speed and tool feed. So as fast as we can go in the lathe but still be safe, I'm running at 2200, and the slower I go with the tool, the better the finish will be, ensuring not to over rub the bevel or allow the bevel to come off. And with a sharp tool, let's just clean up the torn grain, and it's not particularly deep, so I don't need to remove a lot of material to get below it. Here we've fixed the torn grain, correct technique, everything's set up right, sharp tool, and reduced the speed of the cut, lathe speed correct. We've got the finish that we desire. Light bit of sanding and that piece would be complete.